Hi there, and welcome to today's mathematics class. For this class, we look at the concept of polynomial and their operation. For this class, we look at the concept behind polynomial itself. We also look at the classification of polynomial, and also we look at evaluating polynomial. Finally, we look at functions of polynomial. In our next other classes, we look at the concept of addition, subtraction, division, and what the multiplication of polynomial. Let us first, we'll start with the introduction to polynomial. So let's start with polynomial and their basic operation. First things first, what's a polynomial? A polynomial is a special algebraic expression with terms that consist of real number coefficient and variable factor with whole number exponent. So I said when it comes to polynomial, we said a polynomial is simply a combination of values and variable. By what I mean is that you have numbers and letters. So when it comes to x, y, z or whatever there, those are called variable. So when it comes to polynomial, it's simply an algebraic expression. By algebraic expression, we mean it's a combination of numbers and letters, not just number. We have what the numbers and letter in the stuff there. For instance, if I have 4xy, this one here, it's a form to which polynomial comes. So you'll be hearing x, y, and z, whatever concept there. So when it comes to polynomial, first things first, there are combining x and y for you, whichever variable, know that. When it comes to polynomial again, we can still express polynomial as exponent. You see this x and y, they can have exponent. By exponent, I mean the power or degree. So I can still come here and put, let's say put 2 here, put 3 here. So this is read 4x cubed y squared. Polynomial can still be expressed in this form. So narrow your mind that this topic you're dealing with now, there's a combination of what? Both variable x, y, and z and numbers. And also those variable can still have what? Exponents, can still have power, as showed you in this case. So this is like the basic concept behind a polynomial. And one thing to note is that an equation or an expression is said to be polynomial if it's more than 4. Now listen, I said an expression or an equation is set to polynomial if it is what there, if it is more than 4. So if I'm having this, look at this. If I'm having this, if I have 3x plus 4y cubed minus 8xy plus 4s cubed y squared. Now look up. Now this is a polynomial. Why? Now here's the idea. How do you spot out a polynomial? It's easy. We said a polynomial must be, I'm saying this, I'll still give you, but I'm just trying to show you guys what it means. So look up, how many terms do I have here? This is 1, 2, 3, 4. I have 4 terms here. Whenever a term is more than 3, it is said to be what there, a polynomial. In this case here, this one is polynomial. Why? It is more than 4. The hint is this. Whenever an expression or an equation is more than 4, it becomes what there? A polynomial expression, or if you want to, equation. That's basically how it works. So I will give you 2 distinct examples of polynomial. I will now show you what you should always watch out for to identify the real polynomial expression. So if I have example, if I have 3x squared y cubed minus 4x y squared plus 18xy minus 5x to power 5 y to power 3, let's say plus 4, and I have 5 over 2 here. Yes. All right, this is example 1. Let me give you, for instance, let's say I have 3x squared y cubed minus 4y squared over x plus 18x y cubed minus 16x squared y squared plus 8. Now listen and listen. I'm giving you these two from my head because I can just assume an equation, right? So I'm assuming this, for instance. Normally, these two are polynomial. Why? I can see clearly these stuff here are more than 4. Let's count. 1, 2, 3, 4, 5. So it's more than 4. It's a polynomial. So no problem. The second one here too, more than 4. This is 1, 2, 3, 4, 5. So it's more than 4. Is what there? It is still polynomial. But which one is the correct polynomial? Now listen. We said, now listen to this idea to save time and stress. Please listen. A polynomial, the denominator of a polynomial, I mean the denominator of a polynomial, the denominator of a polynomial should not be expressed with a variable. Now listen, check this part here. I'm having a mixture of x and y, no problem. We have cubed, all this, whatever. We said initially that we said initially that when it comes to polynomial, it comes in any form. X and y, you'll be having exponents there too. So this is what I'm having here. It is in both. But here's what we watch out for. Denominator here was 2, was a number. Here was x variable. In polynomial, you don't express denominator of any term as being variable. So this one here is a wrong form of what? It's still a polynomial, but what there in a wrong form. Why? We said do not express denominator of a polynomial as either x or y or any variable. It's not proper. So likely use what there a value. So I'm saying that this one here is the correct form of a polynomial. This man here is the wrong form. Here is what to spot out. Please check your equation. Check denominator. If it's x and y that is there, please, it's not a polynomial. As in this case, when I take everything true, this one we're having over x. We said the denominator should not be either x or y or any variable at all. It should be what there a value. As in this case here, it was 2 here. So this become yet the normal proper form of a polynomial. Having said this, let's look at some important concept to note before we proceed. So subheading, please note the following, please. Subheading, note the following. Note the following. All right. Number one, I'm basically giving you bulletin, right? So faster way to understand this concept. So let's look at some first concept to note when it comes to polynomial. Number one, please. Number one, the constant term, degree, the degree of the constant term in a polynomial, in a polynomial is equal to 0, is equal to 0. All right. The very first thing to note when it comes to polynomial is that number one, the degree of the constant term in a polynomial is equal to 0. Now listen, if you check this one here, that I've said is correct. Which one is a constant term? In mathematics generally, a constant term is simply a number that doesn't have either x or y attached to it. A constant term is simply a number that doesn't have either x or y attached to it. In this case, this 4 and 8 stands alone. In that case, they become what the constant term. Why? There was no x or y attached to this 4. So this 4 becomes what the a constant term. And I'm saying this that the degree or the power or the index of a constant term is in a polynomial is equal to 0. Please know this man. Number two, number two, the degree of a term, the degree, the degree, the degree of a term in a polynomial, the degree of a term in a polynomial, is simply the exponent of the variable. of the variable but if the variable is more than one, hence the degree becomes the sum of the degree of the exponent. The sums of the degree of the variables of the variable. All right. This is another important thing to note when it comes to polynomial. Number one, I said if I have a constant term, by constant term, a term does not have x and y. So the degree becomes 0, no problem. Number two, we said the degree of a term in a polynomial is simply the exponent of the variable. It's easy. Now, listen and listen. If I have 3x squared, 3x squared is just a term, right? Now, look at this, please. This minus plus minus separate terms. So this term one, first term, second term, third term, fourth, and fifth. So if I should bring out a term, I'm having a term this way. If I'm asking you, please, what is the degree of this term in a polynomial? The degree, you said the degree of a term, something like this, a term in a polynomial is simply the exponent of the variable. What's the variable here? X squared. What's the power? What's the exponent here? 2. So the degree of this term is 2. Why is it 2? Because 2 is the what? The power or the index or the exponent of this variable. Listen to English. The degree of a term in a polynomial is simply the what? Exponent of the variable. That is the degree of a term. This is a term. The degree becomes what? The exponent of this variable, which is 2. This is how I spot out the degree of a term in a polynomial. This is how you spot out degree of a term in a polynomial. And I said again that, but if the variable is more than one, that is, for instance, I'm having 3x squared. Now, variable is 1 here. Let me attach y cube, for instance. If the variable is more than 1, it's not just x now, but x and y. More than 1, then hence the degree becomes the sum of the degree of the variable. So my degree in this case becomes what? Sum of the what? The exponent here. So 2 plus 3 gives, 2 plus 3 gives you 5. So my degree becomes what there? 5. Now watch out. A term, the power of that variable gives you the degree. For it's still a term, but I'm having what? 2 or more variables. To get a degree, add the power of the variables together, that gives you 5. So I've shown you how to spot out degree of a term that has more than one variable, and also the degree of a constant term. That's 1, 2. The last thing to note, please. Last thing to note, number 3. Okay, before then, let me take an example to explain 1 and 2 better. Example to explain 1 and 2 better. All right. I'll write expressions outside that will give you the degree. Okay, terms. Let's start with terms. Let's start with terms. Terms and then degree. All right. Let's get out questions. This here is 3x squared, 6x squared y, 7a squared b cube. I have 8 here. I have 2x. All right. Let's explain 1 and 2 better. Now listen. I'm giving you terms. Now when you say terms, don't get confused. Terms are just family. I'm saying this. 3x squared y cube is a term on its own. before you now meet 4xy squared is a term on its own. Family, 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 like this, and this is the idea. Minus and plus, segregate them. So in this case here, this 3x squared alone is the term. 6x squared y is a term on its own. So these are what terms on their own. Now, if I ask you, what is the degree of these terms? The degree, what's the degree? Now, observe here, 3x squared. 3x squared follows the rule that says the degree of a term in a polynomial is simply the what? Exponent of the variable. What is the exponent of this variable here? Is 2. So the degree is square per se. That gives the degree is what? Is 2. Why is it 2? Because 2 is simply what? The exponent of the variable. Now, this number 2 here signifies a mixture of more. This is more than one variable. So for more than one variable, you said the degree becomes the what? Sum of the degree of the variable. X is 2 here, y is invisible 1. There's an invisible 1 here. So if I had 2 plus 2, that gives you 2 plus 1, that gives you 3. The degree here gives you what? That gives you 3. That's place. If I'm to ask you here, what is the degree of 7 8 squared b cubed? It's easy. I'm having two variables, a and b. The idea is easy. To get the degree, sum the part together. 2 plus 3 gives you 5. That's all. 5, 8. In this case, 8 is a constant term. Why? It has no either s or y attached to it. In that case, because what a constant term, we said the degree of a constant term in a polynomial is what? Is equal to 0. The degree here is what is 0. That's all. Finally, I'm having 2x. For 2x, what is the degree of 2x? What's the degree here for 2x? If I'm saying here was x squared, why I attach y? Because anything this way is simply one that is there. So I'm having what invisible 1 here. So what's the degree of this one here? Is 1. The degree of this one here is what? Is 1. This is how to spot out. Please listen. This is how to spot out degree of a term, not degree of a term in a polynomial. It's just degree of a term alone. I've shown you how to identify, how to get the degree of terms, right? Each family is this way. We did it individually. So how do you get individual terms? This is how you get the degree of each individual terms. Let's go to note number 3. Number 1 to number 3, please. Note number 3. The third thing to note. Third thing to note. Third thing to note. Number 3. Number 3. The third thing to note. The degree of a polynomial. The degree of a polynomial. Now, here was the degree of a term. Terms 1 1 1. But now in this case, now because what the degree of a not term, but what a polynomial. So the degree of a polynomial is the largest. Is the largest degree of all its terms. All right. Note number 3. It says the degree of a polynomial is the largest degree of all its terms. Now listen. There's a difference between degree of a term and degree of polynomial. For degree of a term, you're having just family to deal with. For degree of a polynomial, they'll give you more than four terms. They not ask you, what is the degree of the polynomial? What do you do? We say it's easy. The degree of the polynomial is what? The largest degree of all its terms. You now check for which one has the highest degree. That one that has the highest degree becomes what the degree of that polynomial. Now, example. To explain this better, example. To explain this better, example. All right. Let me give you polynomial here. Polynomial, and then let me give you degree. All right. So I'll give you a polynomial example, and then we'll find the degree of the polynomial. 4x upon 5 minus 3x cube plus 2x minus 1. Next up, I have 6x squared y minus 5xy cube plus 7. I have 12x plus 54. All right. Let's get the degree of polynomial. Here was terms. As you can see the difference. Here was just terms. 1, 1, 1. Here was what? A combination of more than one. And then you have to find degree. So what's the degree in this case? Don't stress. We know that there are many degrees here, many degrees here. But here's the idea. We said the degree of a polynomial, something of this nature, is the what? Largest degree. Which one has the largest degree? Here was 5 here is here. Here is 3, here is 1. So which one has the largest degree? The largest degree here occurs at this first term here. That's 4s to the power 5. So 5 here is the largest degree. So my degree here becomes what there? 5. So the degree of all of them here is 5. Why is it 5? Because 5 is what? Is the largest degree of all its term. All this term here, the largest one there is 5. So 5 becomes what? The degree of what? This polynomial. That's how it works. For this one here, if I'm having 6x squared y minus 5xy cubed plus 7, what is the degree of this polynomial? It's simple. Check out for the one that has the highest power. Here is 2, here is 3. There is what? Is 3. So for this 3 now, here is the highest power. So the highest power exists in this one now. So this one now is not a term. Like something like this now is not a term. So what's the degree of this term? We said the degree of this term now becomes, I'm having x and y. So you add the power, 1 plus 3, that gives you 4. The degree here is what? Is 4. In this case, the highest power existed in this part here. So I'll take this one as a term now. If I'm having 4s5 as a term, for instance, as a term, if I'm having 4x to power 5, for instance, from here, the degree becomes what there? The 5 there. So 5 becomes the degree. Similarly, in this case here, the highest existed here. So from here now, the highest power here is 5. In this case, there's two variables attached to this, the one with the highest power. There's two variables there. So the power becomes the sum of the variable. As we said that, but if the variable is more than one, like more than one, the highest existed in this part, but this part here has more than one variable. Hence, the degree becomes the sum of the degree of the variable. So I'm adding 1 plus 3. That gives you 4. For this part here, what is the degree of the polynomial? The polynomial here is what? Is just 1. Right? So the degree here is 1. This is how to spot out or identify the degree of a polynomial and degree of what? A term in a polynomial. Please listen and listen. Get to understand note number 1, number 2, and 3. They're the key parts to understand this concept much more better. I want to say this. Let's look at another important concept in under let's look at another important concept under polynomial known as classification of polynomial. Welcome back. Let's look at another concept under polynomial called classification of a polynomial. So let's look at classification of polynomial. All right. Now, there are four classes or there are four categories we can classify polynomial. Number one, there we have the monomial. Number one is called monomial. Number one is called monomial, which means just one term. If you have one term, that's monomial. Number two is called binomial. Binomial. That's when you have two terms. Two terms. Number three is called the trinomial. Trinomial. When you have three terms. And finally, we have number four, we have the polynomial. Polynomial. That's when you have more than three. So this when it's more than three. So that becomes, you call it what? A polynomial. Now, when it comes to polynomial, that there are four ways you can classify them. Number one is called monomial, binomial, trinomial, and polynomial. Something is said to be monomial if it's just what? If it's just having one term. So a one-term expression signifies monomial, a two-term expression signifies binomial, a three-term expression signifies what there? Trinomial, and finally, more whenever a term in a polynomial is more than three, it's said to be what there? A polynomial expression or equation if you want to. So to better understand this concept of monomial, binomial, trinomial, and polynomial, we'll take an example under this and explain this concept much more better. All right, let's try to work on this, please. First, we said there are four: monomial, one term; binomial, two terms; trinomial, three terms; and polynomial, more than three. Now look at this part here. We are asked to, for these expressions here, we are asked to state two things. Find the classification of each of them, and also what? Find the degree of each of them. I have done degree for you recently now. So don't forget the idea of degree, right? There are basically three things to watch out when it comes to degree. Number one is what? The degree of a constant term is zero. Number two is what there? The degree of a term in a polynomial is simply what there? Is simply the power or the exponent in that variable. But if you have more than two variables in a term, the degree becomes what the sum of what? Each individual variable, the degree of individual variable in that polynomial, as we said earlier. Now, in this case here, I'm asked to set the classification and degree. If I'm having 5s to power 7, what classification will it fall? This one here is just a term. A one term signifies what there? A monomial. So this one becomes what there? A monomial polynomial, right? This one here is one term and second term. This is two term, one and two. I'm having two terms here. For two terms, that becomes what there? A binomial. So this expression is called what there? A binomial. Binomial polynomial or expression if you want to. This one is what? 1, 2, 3. That becomes what there? A trinomial. That gives you trinomial, right? Finally, this one here is 1, 2, 3, 4. This is more than 3. For more than 3, that gives what there? A polynomial. So this one is called polynomial. And I said initially before now that a polynomial is simply an expression that's more than what? More than 3. So in this case here, this is more than 3. So because what the a real polynomial expression. Let's get a degree, please. If I'm having 5s to power 7, degree here is 7. All right. By now, you should know this. Degree of a term in a polynomial is the power or the exponent there. Exponent here is what? Is 7. That becomes 7. What's the degree here? So this is what? Terms. This is a polynomial now in this case. This is polynomial, not a term. This is just a term. This one now is a polynomial. This is note number 3 that I gave you before. Note number 3. Check note number 3. I said the degree of a polynomial is simply what? The one with the highest power. The term with the highest power. I'm having s to power 6 and 1. 8x to the power 6 and 1. Which one has the highest power of the variable? Is 6. This one here. So for this one, 8x to the power 6, what's the degree here? Is 6. That gives you 6 degree. I'm having 1, 2, 3. For this 1, 2, 3, which one has highest power? Highest power is 2. This one has the highest power here. For this one here, minus 3x squared. What's the degree here? Is 2. That gives you 2. 1, 2, 3, 4. More than 3, more than 4. So now in this case now, which one here has the highest power? The highest power, I can see that it is in this part here. 5x cubed. This one has the highest power. So for 5x cubed, what's the degree of 5x cubed? Its degree is what? Is 3. So this is how to spot out the classification of a polynomial and degree simultaneously. So this is how this concept of classification of polynomial works. Let's take a sample problem and see how that works. Let's take an example. Sample problem. Sample problem. Let's solve a problem and see how that concept works. Welcome back. So let's solve this sample problem. It says classify and state degree. So classify each of them at the same time state degree. For number 1, I'm having 7x squared minus 4x5 to the power 5 minus 1. This is 1, 2, 3. For 3, that gives you trinomial. So this one is called a trinomial. Degree what? Now, what's the degree here? We said to spot out degree in a polynomial. Check which term that has the highest power. I'm seeing 4 is to the power 5. This one has the highest power. So the highest power here is 5. So if I'm having 4x to the power 5, what is the degree of 4x to the power 5? The degree is 5. So this is trinomial degree 5. Degree 5. So this equation here, it's simply a trinomial equation and also what? A degree 5. This one here is a term. Yes, there's no plus and minus here. You just stand alone. So it's a what? It's a term. So this term is just one term. So for one term, that's what? A monomial. So this man is called monomial, right? Of course, what degree? Degree what? What's degree here? We said this one here has more than one variable. It has A, B, C. The degree in this case become what? The sum of the power. That's 5 plus B is having an invisible 1 here. That's 5 plus 1, that's 6. 6 plus 3, that gives you about 9. So the degree here is what? Is 9. All right. Degree in this case is 9. Finally, this one here, what classification is it under? This 1, 2, 3, 4. This is more than 3. So more than 3. So it's like 4 expression here, 4 terms here. So it's a what? It's a polynomial. This man is a what? Polynomial. So what degree will this one be? What degree? Degree. What degree is this? We said to put out degree in this case. Check on the one that has the highest power. Which term has the highest power? Of course, if you observe that 4 was having the highest power here. But if you observe that if 4 is having the highest power here, S here is 1. So 4 plus 1, that gives what? The 5. But if you observe, look at this one, they're having 3, 3. So this one has the highest power because y is having 3, x is having 3. Yeah, y is having 4, x is having 1. So 4 plus 1 gives you 5, 3 plus 3 gives you 6. So in this case here, the highest power goes to what? This one here. Goes with this one here, and that's 6. So I'm having what there? I'm having 6 here. So this is my, so I'm saying this. If you observe normally, he was having 4. So you confuse that this one here is 4, and being 4, you assume it is the highest power, but no. Observe this. X is 1, y is 4. 4 plus 1 gives you 5, pending. Keep it pending. This one here, y is 3, x is 3. That gives you 6. In between 6 and 5, which is the highest there? Highest is 6. And we said the rule says go with the one that has the highest. So of course, the highest is 6. So I'm having what there? 6 degrees 6. This is how you spot out classification of polynomial and what have you concept there. At this junction, let's look at another concept called the arrangement of a polynomial. How do you arrange polynomial correctly? Is there a proper way of writing the polynomial? Yes. Let's look at the concept of arrangement of a polynomial. Hello, future engineers. I need to make a very important announcement. Please stop messaging me on WhatsApp for homework assignment. My phone is currently crashed because I have over 10,000 students messaging me every single day. It's impossible for me to reply everyone and still have time to teach. So here is the new rule. I have officially launched the engineering support membership. If you want me to answer your question or solve your calculation, you must click the join button below. The join button below for just 600 naira a month, which is less than the price of a meat pie. You will get a special green badge next to your name. Here is my promise. When I scroll through a comment, I look at the green badge first. If you are a member, I stop everything and answer you immediately. My WhatsApp is closed for free help. If you message me there, you will get an auto reply sending you back here. The membership is one of the guaranteed ways to get my attention. Click join right now and get your badge. And let's succeed together academically.